And myself, Akilapriyadharshini from the Department of Civil Engineering, VSB Engineering College, Karur. And today we are going to see about the unit of two structure analysis one, the slope deflection method. The slope deflection method is to find the joints and the deflection that is made by the determinate, indeterminate and the frames and the continuous beams of the structure is found out by using the method slope deflection method. In this method, we can find the equations of both continuous beams as well as the frame, and which includes sway and without sway, and the sway is the definition that comes under the loading of corner joints that makes the structure to deflect in a certain distance is a sway. And these are all the overview of this unit where we will learn the slope deflection equations and equilibrium conditions and the baseline structures such as the continuous beams and the rigid frames and the real world variables of support settlements and the sway and the advanced geometric of inclined members and optimization of symmetric and skew symmetric loading. And the concept of slope deflection method where the flexibility is found out by using a flexibility method and the displacement is found out by using a stiffness method. But these units can also be found out by using the slope deflection method, which includes the theta values of loadings, and the deflections are found out and measured by using the value of theta. And this is the equation of slope deflection equation where it describes the moment that occurs in the end of A and B, which includes the final end moments at B, and 2 I divided by L is effect of near end slope, and the 2 theta A will be the near end slope and the theta B will be the far end slope, and the 3 del L will be the effect of settlement that occurs in the real world examples. And the joint moment, the equilibrium condition that occurs between the beam A, B and C. The equilibrium condition will occur at the joint B where it includes MBA and MBC. In first step, we will find the expressions in terms of theta, that is by using the slope deflection method. And in the step 2, we will find the moment of joint equilibrium, and then we will solve these equations and the rotations of the value theta. And this is the application for the continuous beam, in which it includes the identification of unknowns, which is of theta B and theta C, and then we have to find out the fixed end moments. Once the moments are found out, we will start writing the slope deflection method equations, which means FEM AB plus 2EI divided by L AB into 2 theta A plus 2 theta B minus 3 del divided by LAB, where FEM AB the final end moments of A and B, and theta A will be the far end near end slopes, and theta B will be the far end slope, and 3 del LAB will be the settlement and accuracy. And after finding this, we will find the joint equilibrium, but in this we will find the equilibrium at joint B and C, where we have found out the rotations. We will find the joint equilibrium. Once it is done, we will go with the final bending moment diagrams. And then rigid frames. Rigid frames will occur. Rigid frames are nothing but the straight and angular members connected with the joints or rigid frames, and when the loading is done at the corners, there won't be any sway. That means without sway will occur at the joints, and there won't be any anchorages needed, and same exact rotation will occur. And then support settlements. In this, we have zero external loadings. Once the loading occurs, it starts deflects like this way, and where the deflection is and the difference of deflection will be found out by using del, and that is what is mentioned as 3 del divided by L. And we can find the reactions both horizontal and vertical. Likewise, we can find the reactions at C both horizontal and vertical. And then rigid frames with sway. If the load acts in this joint from the left side or the right side, there will be some sway towards the left side. That is what is mentioned as del, and this will be considered for the horizontal translation, and where the moment is 0 alone we can't solve the system. And then rigid frames with an inclined members, where the loading will occur in an inclined way, the frames will also sway to the inclined way, and where these are found out by using an angular member of using a right angle triangle, where it has a vertical reaction, horizontal reaction, and a moment towards it. And then the diagnostic matrix of orthogonal versus the inclined sway. Here the member displacement will be the straight horizontal one, where in the inclined portal frame, the slanting legs will be the inclined one, where it provides a right angle triangle, where the relationship will be the column is equal to the horizontal, where here the member is not equal to the horizontal. And then the joint rotation will be the simple independent rotation, and it is highly independent to the sway geometry. Because it has an inclined one. If the loading occurs in the inclined way, the sway occurs, the del value will also change with respect to the right angle triangle. And then the shear equation, it straightens forward to the base shear and resolves all moment equations and forces into the horizontal members. And then the mathematical elegance, here the rotation will be the right is equal and minus to the theta right, which is equal magnitude of opposite direction. The frame will not sway laterally, that is why we are not considering it. And then the hidden symmetry, where the theta left is equal to theta right, which is of equal magnitude and same direction, that is done in skew symmetric loading. And here the loading is occur from the right side, where the theta L will be from the left side as well as the right side is occurs, and the axis of symmetry is of same, and there won't be any variation with respect to this. And then this is the flow chart that explains the continuous method of both the continuous beam and the rigid frames, and the geometrical and symmetric way everything is occurred. Here the frame is first identified and the loading is checked. Once the loadings and lateral loadings and symmetric asymmetry are yes, they will go with the sway frame or the non-sway frame, where the joint equilibrium condition m is equal to 0. Here the summation h, which is of summation of horizontal, is equal to 0. Or the columns are vertical, they will go with the substitution of del value, or they will go with the trigonometric compatibility, which is of a right angled inclined sway equation. If it is satisfied, they both go with the geometric perfectly symmetric. If it is okay, they will go with apply symmetric equation, and then we can find the for simultaneous equation of slope deflection method. And the limitations of SGM, which means a slope deflection method, it is a mathematically perfect universal tool for determining beam and frame displacement. Since we have a stiffness method, and this is the equation where the slopes are find out, as well as the rotations that occurs during the moments is also found out here. And then the limitations, hand solving equations or simultaneous equations become impossible, and becomes the structure highly indeterminate, and it is not suitable for multi-story structure. Since it is a tedious structure, we will go with the moment distribution method and the iterative method, and base a way for the matrix flexibility method, and then the matrix stiffness method. From this, we will learn the slope deflection method in an easy way, since it has the equations, and when we find out the final fixed end moments, the unit will be highly easy for the students to understand and easily analyze the structure in an easy way.